I'll make my presentation regarding development of analog 3D food printing ink for the personalized senior friendly foods. This study attempts to develop an ink for food 3D printers containing abalone powder and several nutrition properties that meet the criteria for senior-friendly foods. To examine the physical chemical properties of the ink, texture, water holding capacity, and rheological properties were measured. In addition, the stability of the 3D printings was examined. In Korea, the senior population is growing quickly as a result of declining birth rate and rising life expectancy. In 2020, it was 50.8%, and by 2060, it is expected to reach to 43.9%. Physical changes due to aging include loss of natural teeth, weakening of coordinations of body movements, and weakening of mastication muscles. As a result, symptoms such as poor appetite, decreased chewing, and swallowing function lead to nutrition imbalance. But Korea's elderly food market is not active due to problems such as lack of awareness, business feasibility, marketability, planning, and technology development compared to global market. Korean industrial standards announced that senior-friendly food should fulfill at least three standards and one physiological property among 9 nutritional standards. Supplying an appropriate concentration and texture of food is important to the athlete, but food that has the texture modified may lose appearance and taste. 3D printing is a stable processing method for personalized food production because it can adjust physical properties by applying various patterns to food, and nutrients can be supplemented by controlling the amount and nutrition of food. Personalized texture can be produced through material density control and change in print internal structure using 3D printing can lead to the development of elderly foods. When 3D printing is applied to food industry, it is important to select a stable printing technology because of the various physicochemical properties of food ingredient. Regarding 3D printing, which is used in this research, In order to ensure smooth printing, the fluidity of the food should be maintained in the pre-extrusion state, and the shape should be maintained without structure deformation when extruding material. Therefore, 3D printing ink should have uniform particles and proper flow characteristics during printing and be able to provide structural stability after printing. Gelatin. Gelatin is frequently used as a gelling agent or stabilizer to provide texture properties for food components. Gelatin is a type of hydrogel made by hydrolyzing protein in collagen and has remarkable physical properties such as dispersion stability, and moisture retention. However, the hard and chewy texture of abalone makes it difficult for elderly people to intake and digest. And research on 3D printing ink related to elderly foods containing abalone is insufficient. Therefore, this case proposed 3D footprint ink containing abalone which can be adjusted in texture according to gelatin concentration. For the elderly who have difficulty in consuming seafood and masticatory function. Next part, materials and methods. Preparation of the 3D print ink with abalone. Abalone 3D printing ink is API. The powder mixing ratio is based on the nutritional standards of elderly food. About 10 grams of abalone powder was mixed with isolated soy protein for protein enhancement, dextrose for dietary fiber fortification, vitamin C, gelatin, and gelatin to prepare the mixture. The sample were named G0, G1, G3, G5, and G7 according to gelatin concentration. Research plan is as follows. First, texture analysis. Hydrones major factor that divides the food stage into 3 in terms of elderly food. The APIs according in gelatin concentrations should a significant increase in hardness. All APIs containing 1 to 7% gelatin met the criteria for the properties of elderly food. The WHC of the API increased significantly with the increase in gelatin addition, indicating that the gel network hardening water was improved. There was no significant difference between G3, G5, and G7, but significantly higher WHC was confirmed compared to G0 and G1. Biological properties of APR. G dash over samples was G higher than G double dash. And there was no intersection point, which indicated that material forming structure, such as a gel, was in an elastic state. 3D printing process conducted to confirm the support of the structure and continuous printing of food ink show the result of measuring the diameter and height of each cylinder. Cylindrical height showed the tendons according to gelatin concentration. Therefore, it could be said that the improvement in mechanical strength was due to the increase in gelatin concentration. Scanning electron microscopy. G0 and G1 showed a coarse surface and fragmented texture. The thicker walls were observed with increasing gelatin concentrations. Gelatin hydrogen matrix increased the thickness of the microstructure was increased and the texture became harder. This is the last part. To conclude, this day reported the invention of 3D printing for elderly foods based on gelatin content, which influence texture. The texture properties of food ink could be adjusted according to gelatin concentration. Increased gelatin concentration can improve the 3D printing performance of food ink. Therefore, the information presented in this study confirmed that the 3D food ink for the elderly is capable of controlling texture and may be applied to the development of elderly foods and the application of 3D printing technology. Thank you.